Okay, our lesson is solving inequalities. And inequalities are solved very much in the way that we solve equations. So in example 1, we need to deal with the plus 4, and we eliminate the plus 4 by subtracting 4 from both sides. So on the left-hand side, once we have subtracted 4, we are left with just 3x, and that is greater than. And on the right-hand side, when we subtract 4, we're left with 18. Don't forget, whatever you do to one side, you must do to the other. We now have 3x, but we want to be left with just 1x. So we divide by 3, and that will leave us x on the left-hand side, greater than, and then 18 divided by 3, that gives us 6. In example 2, the first thing we deal with is the 5. Now, some people would think that we would be adding 5 because of this subtraction here. It's really important you understand that that subtraction belongs to the 2x and not to the 5. So that 5 is a positive 5. We want to get rid of it. And in order to get rid of positive 5, we subtract that 5. Now, when we subtract the 5 on the left-hand side, we're left with that negative 2x. Then the inequality is less than or equal to, and on the right-hand side, when we subtract 5, don't forget we must do to one side what we've done to the other, we're left with 12. And then we need to deal with the negative 2, because we've got negative 2x, so we divide both sides by negative 2, and here's a really important step coming up. When we divide negative 2x by negative 2, we're left with x. But the really important step is, because we're dividing by a negative, we change the direction of the inequality. So you can add and subtract numbers with inequalities, and that's fine. But whenever you multiply or divide by a negative, you change the direction of the inequality. Well, we've divided by a negative 2 there. So our less than or equal to changes direction and becomes a greater or equal to. So this fact here, you just have to remember. And on the right-hand side, when we divide 12 by negative 2, that gives us negative 6. Here in example 3, we've got a double inequality. So let's treat the left-hand side of that separately from the right-hand side. So when we treat that separately from the right-hand side, that's the inequality that we're solving. So we would subtract 4 from both sides, negative 6 less than or equal to 3x, and then dividing by 3, because we want to go from 3x to 1x, divide both sides by 3, and on the left-hand side we're left with negative 2, and that's less than or equal to x. So that's 1/2 of our answer, and I'll just put that over there underneath the question. The second part of the inequality is the right-hand side, which is 3x plus 4 is less than 13. Once again, we subtract 4 from both sides, leaving us with 3x on the left-hand side, less than 9 on the right-hand side, and then dividing by 3, x less than 3. So that is the other half of our answer. So our answer is saying that x is greater or equal to negative 2 on one side, but also x is less than 3 on the other. And we put that together in a single inequality like that. So x is greater or equal to negative 2, but x is also less than 3. And that's how you deal with a double inequality. You treat them as two separate ones.